Linear phase realization of FIR filter. Linear phase means if the impulse response is symmetrical about its origin, it is called as a linear phase. That means the values are same. The values are going to be same. Okay. That means if the impulse response is symmetrical means the values are same. Okay. About its origin. Mathematically we can represent it as h of n is equal to h of n minus 1 minus n. That means the h of n will be symmetrical with h of n minus 1 minus n. Okay, we can consider an example. Suppose h of n is given like that 1, 2, 3, 4 and 1. That means the total length of the sequence is 5. 1, 2, 3, 4, 5. So the total length of the sequence is n is equal to 5. Then according to this equation, h of n is equal to h of n minus 1 minus n. Okay, that is if n is equal to 0 and capital letter n is 5, then how will we write? H of 0 will be equal to h of 5 minus 1 minus 0. That means h of 0 is equal to h of 4. H of 0 and h of 4 are symmetrical. Similarly, h of n, if n is equal to 1, then h of 1 is equal to h of n minus 1 minus n, that is h of 5 minus 1 minus 1, which is equal to h of 3. That means h of 1 and h of 3 are symmetrical. Okay, this symmetric property is known as linear phase. Okay, the equation is h of n is equal to h of n minus capital letter n minus 1 minus n. Okay, now let's write the equation. H of z is equal to sigma n is equal to 0 to n minus 1 h of n z raised to minus n. Okay, here it is having two cases. That means if the n values even, we will consider first case. If n values odd, we are considering another phase. Okay, first we will consider n is even. What happens if n is even? That means h of z will be equal to sigma n is equal to 0 to n by 2 minus 1 h of n z raised to minus n plus sigma n is equal to n by 2 to n minus 1 h of n z raised to minus n. Okay, which is equal to sigma n is equal to 0 to n by 2 minus 1 h of n z raised to minus n plus I am changing the limit here. Here I am changing it to n is equal to 0 to n by 2 minus 1. So if these limits are changed, I am changing z raised to n minus 1 minus 1. Okay, then taking sigma n is equal to 0 to n by 2 minus 1 h of n as common, I am getting z raised to minus n plus z raised to minus of n minus 1 minus n. Okay, this is the equation for when it is even. Okay, h of z is equal to sigma n is equal to 0 to n by 2 minus 1 h of n z raised to minus n plus z raised to minus of n minus 1 minus n. We can consider let capital letter n is equal to 4. Let n is equal to 4, then h of z will be equal to sigma n is equal to 0 to n by 2 minus 1 h of n z raised to minus n plus z raised to minus of n minus 1 minus n. This is the equation. So here capital letter n is equal to 4, then sigma n is equal to 0 to 4 by 2 minus 1. That means 1 h of n, okay, z raised to minus n plus z raised to minus of n minus 1 minus n, which is equal to what is the first value? N is equal to 0. That means h of 0 into z raised to 0 plus h of 0 into z raised to minus of capital letter N is 4 minus 1 minus 0. Okay, these are the values when h of n is equal to 0, plus when n is equal to 1, that is h of 1 z raised to minus 1 plus z raised to minus of 4 minus 1 minus 1. Okay, this will be equal to h of 0 is equal to z raised to 0 means 1 plus z raised to minus 3 plus h of 1 into z raised to minus 1 plus z raised to minus 2. Okay. Okay. Now, how we are going to draw the realization of the structure. Okay. The maximum power is what? The maximum power is 3. So, we need 3 z raised to minus 1 term. That means 3 delay terms are there. I am gonna realize the structure. So, it is having maximum of 3. So, 3 delay structure. So, if n is even, we will draw like this. If there are 3, 1 z inverse here, 1 z inverse here, z inverse and z inverse. Okay. First case, okay, here the output is z raised to minus 1. If z inverse into z inverse, here the output is z raised to minus 2, which is multiplied by here the output is z raised to minus 3. Okay. In this equation we can see that 1 plus z raised to minus 3 we need. So 1 and z raised to minus 3 are multiplied. So from here we will get z raised to minus 3, which is added with term 1. Okay. 1 plus z inverse. So z inverse, we get z inverse from here and 1 from here. Okay, 1 plus z inverse, which is multiplied with h of 0. So I am drawing one multiplier term here, which is multiplied with h of 0. Okay, then what is the next term? Z raised to minus 1 plus z raised to minus 2. So I am getting z raised to minus 1 from here. This is z raised to minus 1, which is added with z raised to minus 2. Z raised to minus 2, I will get z raised to minus 2 from here, which is added and multiplied with, so z raised to minus 1 and z raised to minus 2 are added and multiplied with h of 1. So it is multiplied with h of 1. Okay, then this two terms are added. Okay, so I am putting one adder here. Okay, these twos are added and we will get the output y of n. From here we are providing the input x of n. So this is the linear phase structure when n is even. Here we consider maximum 3 delay terms. Okay, we can generalize this linear phase structure. Okay, that means we can generalize it like this. If there are lot of multipliers here. Okay, here one z inverse, z inverse, z inverse, z inverse, z inverse. Okay, then these two are symmetric one. These twos are added and multiplied with h of 0. Then these two are symmetric, which is added and multiplied with h of 1, like that. Here added and multiplied by h of n by 2 minus 1. and all these terms are again added to get the y of n. Here x of n is provided. Okay, this is the general structure when n is even. Okay, that means symmetric terms are added and multiplied with the coefficient. These are the, here z inverse and this term is symmetric, so it is added and multiplied with h of 0. Okay, this is the general structure. Now let's check number of multipliers needed. Number of multipliers needed when n, capital N is even is n by 2. This is very important. How many number of multipliers required? Okay, if the length of the sequence n is equal to even, then the number of multipliers required is n by 2. Okay, now let's check the second case, that is if n is odd. If n is odd. If n is odd, then we will rewrite the h of z equation as h of z is equal to sigma n is equal to 0 to n minus 3 by 2 h of n z raised to minus n plus sigma n is equal to n plus 1 by 2 to n minus 1 h of n z raised to minus n plus h of n minus 1 by 2 into z raised to minus of n minus 1 by 2. This is actually a very lengthy equation, but if you are doing the problem, it seems to be a simple one. Okay, so this is the general equation when n is odd. Let's consider if n is 5. Okay, we can rewrite the equation as h of z will be equal to n is equal to 0 to 5 means n by 2 n minus 3 by 5, that is 5 minus 3 2 by 2, that is 1. Then h of n z raised to minus n plus sigma n is equal to n plus 1 by 2, that is 5 plus 1 by 2 3 to n minus 1, 5 minus 1 4, h of n z raised to minus n plus h of n minus 1 by 2, that is h of 4 by 2, h of 2 into z raised to minus of n minus 1 by 2, that is 5 minus 1 4, 4 by 2 2, z raised to minus 2. This is the general equation when n is equal to 5. Okay, so we are expanding this equation. Here n is equal to 0 and n is equal to 1, that is h of 0 z raised to 0 plus h of 0 z raised to minus 1. Okay, plus h of 0 z raised to 0 plus h of 1 z raised to minus 1. So this term is over. Now consider n is equal to 3 and 4, that is h of 3 z raised to minus 3 plus h of 4 z raised to minus 4 plus next term h of 2 z raised to minus 2. Okay, so these are the terms we got. H of 0 into z raised to 0, z raised to 0 means 1, then h of 1 into z inverse, h of 3 into z raised to minus 3, h of 4 into z raised to minus 4 plus h of 2 into z raised to minus 2, if the length of n is equal to 5 according to our equation. Okay, we substitute the values and we got an equation like this. Now we gonna draw the structure of this. Okay, the maximum z inverse term is 4, so we need 4 z inverse term. So I am drawing the z inverse term in such a fashion that 1 2 3 4 z inverse z inverse z inverse z inverse. Okay, here You can see that in this equation h of 0 and z inverse term, the coefficient of h of 1. Okay. Here z inverse coefficient, and this is the fourth z inverse term. Here z inverse, z raised to minus 2, z raised to minus 3, z raised to minus 4. These two coefficients are 1 plus and z inverse coefficient are added and multiplied with h of 0. Okay. The next is, just rewriting this equation will be better. H of 0 is equal to 1 plus z inverse plus h of 3 z inverse plus h of 4 z raised to minus 4 plus h of 2. I hope you can see this. I am only rewriting this equation, z raised to minus 2. So while drawing the figure, here first 1 plus z raised to minus 4 coefficient are added and multiplied with first coefficient h of 0. Then z inverse term and z raised to 1, 2, 3, z raised to minus 3 terms are added and multiplied with h of 1. Okay. Then z raised to minus 2 term. Last term what? Z raised to h of 2 into z raised to minus 2. That is z raised to minus 2 into h of 2. These all terms are added to get y of n, and here x of n is provided. Okay. In the case, this is the case when the n is odd. So last case, when the n is even, the number of multipliers required are n by 2. Here the number of multipliers required are n plus 1 by 2. In this case, 5 plus 1 by 2, 3. 3 multipliers are required. That is h of 0, h of 1 and h of 2. 3 multipliers required. Okay. Let's check into a problem how to draw the figure. Okay. The question will be asked like this. Realize using minimum number of multipliers. Okay. The question is like this. That is h of z is equal to 1 by 2 plus 1 by 3 z inverse plus z raised to minus 2 plus 1 by 4 z raised to minus 3 plus z raised to minus 4 plus 1 by 3 z raised to minus 5 plus 1 by 2 z raised to minus 6. Okay, this is the question. So what is the value of n? N values, n is equal to 7. Am I right? Okay, n is equal to 7. Now n is equal to 7 means the odd, n is the odd. So the second type of realization we need. That means first you check what are the common coefficients. Here 1 by 2 coefficient here, and another coefficient z raised to minus 6, same 1 by 2 coefficient. Okay. Now 1 by 3 coefficient for z raised to minus 1 and z raised to minus 5. Similarly 1 by 4 coefficient for z raised to minus 3 and one more term is there. One second. Okay, z raised to minus 3, only 1 by 4 coefficient. Okay, that's all. 1 by 2 coefficient, everything is over. 1 by 2 coefficient for 1 plus z raised to minus 6. I am rearranging this equation, that is 1 plus z raised to minus 6 plus 1 by 3 z inverse plus z raised to minus 5 plus just the thing z raised to minus 2 and z raised to minus 4, coefficient is 1, that is z raised to minus 2 plus z raised to minus 4 plus 1 by 4 z raised to minus 3. So the common coefficients I have taken it as common, okay, and inside the z terms are included. Here z raised to minus 6 is symmetric with z raised to 0. Then z raised to minus 1 and z raised to minus 5 are symmetric. Z raised to minus 2 and 4 are symmetric, and another term. Okay, so if this is a what kind of odd thing, so we are drawing like this. We need 6 z inverse term. We need 6 z inverse term. Okay, z inverse, because the question is up to z raised to minus 6, so z inverse term, z inverse, z inverse, z inverse, z inverse. Okay, then here 1 plus z raised to minus 6. Z raised to minus 6 what means? Here z raised to minus 1, z raised to minus 2, z raised to minus 3, 4, 5 and 6. Here you got the z raised to minus 6 value. Okay, this z raised to minus 6 value and 1 is added and it is multiplied with a constant 1 by 2. Now z raised to minus 1 and z raised to minus 5 are added. Z raised to minus 1 means what? Here, and z raised to minus 5 means 1, 2, 3, 4, 5 here, which is added and multiplied with a constant 1 by 3. Now z raised to minus 2 and minus 4. Minus 2 means here, 4 means 1, 2, 3, 4, which is added and multiplied with 1. And another term z raised to minus 3 into 1 by 4. Minus 3 means 1, 2, 3. Here z raised to minus 3 is multiplied with 1 by 4. All these terms are added. All these terms are added to get y of n. Here input x of n is given. Okay, I hope you understood this. All these terms are added to get the y of n and x of n is taken. Okay, so let's check number of multiplies. If n is n is odd, so the number of multiplies required is n by n minus 1 by 2. That means 7 minus 1 by 2, that is 6 by 2. 3 multipliers required. Sorry, n plus 1 by 2, not n minus 1 by 2, n plus 1 by 2, that means 8 by 2. 4 multipliers required. So here 4 multipliers, 1 is 1 by 2, 1 by 3, 1 and 1 by 4. 4 multipliers required. This is the type of realization when n is equal to odd. Okay.